Excellent. Okay, so as you can see, the title of this talk is fairly self-explanatory, but the motivation for the talk is not that simple. I hope that it is a timely talk. Basically, I've designed this talk because I am very worried and at the same time hopeful. I'm worried because there's a conversation that is starting and sort of heating up in our industry very, very quickly, perhaps too quickly. And the conversation is going in a certain direction that is not necessarily all that great. So in this talk, I want to put the brakes on some of that discussion and perhaps steer the discussion in a slightly different way. And the good news is other people are doing this as well. So when I'm going to Java 1 or I'm going to DevOps, there are people in Java 1 and DevOps that have essentially the same things to say that I will share with you today that you may or may not have heard of before with regards to microservices. Okay, so that's a little bit of a hint as to what it is that I plan to accomplish. Let's talk about the title of the presentation, Down-to-Earth Microservices with Java EE. Clearly you've heard of microservices before, and that's why you're in this room, I hope. What does the down-to-earth part mean? It means that I am not up here to be a cheerleader for microservices. Instead, what I plan to do is give you a more realistic and down-to-earth view of how you may approach microservices and how you may evaluate whether this is something for you or not. Of course, the other interesting keyword in my talk is Java EE. Shouldn't surprise you since I'm the one delivering this talk. We will be talking about how you can go about creating microservices using really nothing much more than just plain Java EE, believe it or not. All right, moving forward. This is how I plan to spend my time, the next about 50 minutes or 45 minutes or so with you. This is not necessarily, it's called the agenda, but it's not really the agenda. These are sort of the goals that I hope to accomplish during this talk. So first and foremost, I do want to stop and try to explain exactly what microservices are. Then I hope to help you answer the question of whether microservices are really for you. And then finally, we'll be spending a majority of this talk today talking about how you may implement microservices using the Java EE platform. All right, so let's get started in the very beginning, which is what exactly are microservices. The interesting part and very dangerous part is that it is incredibly vague. Okay, so and this is a very, very problematic situation. If you cannot understand what microservices are, you have absolutely no hope of implementing it correctly. So its first step is first understanding what this thing is really all about. Now, the other scary aspect of all of this is the naming and religion going on around microservices is very, very vague and very, very troublesome as well. And it all starts with the name itself. The reality, as I will explain to you, is that microservices are neither necessarily micro and neither necessarily services. And that will tell you a little bit about what is going on in terms of the hype versus reality of microservices. In fact, what I see as sort of a disinterested third party is that this is a term that has already been hijacked and overloaded by commercial interests, and it's going farther and farther away from the kernel of truth, what is really valuable about this concept, and I hope to try to correct that during my talk. The other bad bit of naming that's in this sort of microservices hype is the so-called monolith. Whenever in our industry we hear a monolith, this doesn't give us a warm and fuzzy feeling. It's a term deliberately designed to cast things in a very black and white, good and evil fashion. But the reality is, like many of things in our industry, microservices are neither good nor evil. They are various shades of gray. And that is what another thing you should understand coming out of my talk today. Now, a bit of history. I think Patrick said if you don't understand history, you can't possibly understand the present, and you certainly will not understand the future. The reality is that these concepts of microservices are not new at all. They have been with us for a very, very long time. We sort of deal with the same sort of problems over and over again and give it a new name each time and deal with it in slightly different ways. And we've been doing this, believe it or not, since the 1970s. So all of these things, Unix, Corba, Ginny, EJB2, EJB1 and 2, COM and DCOM, OSGI, and most recently, SOAP and ESBs, believe it or not, deal with the same problem, and the problem that we'll be talking about very, very soon. In fact, a very intellectually honest name for microservices should have been SOA2. Okay, or son of SOA. Because in reality, SOA and microservices have much more in common than they have differences. So let's now, given that historical context, try to arrive at a sane, reasonable definition of, or understanding of what microservices really are. I've grappled with this problem quite a bit. If I cannot define this, I cannot possibly do a talk on it. So after thinking quite a bit about it and bantering about various ideas, this is the most basic definition that I have been entirely comfortable with. I'm 100% comfortable with this definition of microservices. I have no problem defending it. So what is it precisely? It is very, very simple. It is simply taking a larger system. Mind you, I didn't say a large system. I merely said a larger system, and decomposing it into smaller. Remember, mind you, I didn't say small. I said smaller, independently deployable parts. That is it. That's the heart of all that this is all about. Take something that's big, and you want to break it down for some reason or the other, and the pieces should be smaller than the original whole, and these pieces should be independently deployable. They should move independent of each other if they need to. Moving more into sort of the dogmatic aspects and religious aspects of microservices, these are some of the other things that you'll hear as to efforts of defining microservices. If you talk to the people that are the most enthusiastic supporters of microservices, they will definitely tell you this is not SOAP, this is not ESB. Okay, so if you're doing microservices, you better not be using SOAP and you better not be using ESB. I partially agree with this statement. I sort of agree with it and sort of disagree with it. I actually do not see any problem with you using SOAP to implement microservices if that is the right technology for your particular situation. I do, however, agree that you shouldn't be using ESBs. In fact, I never, even in the era of ESBs, in the era of SOAP, I've always said we do not need ESBs, and that continues to hold true even today. But it's a bit more crystallized because of the religion, if you will. So definitely the microservices, the high priests of microservices will tell you, you better not be using ESB, which I can agree with. The purists of microservices will tell you that we should mostly be using REST, and mostly be using messaging if we need to. In terms of Java, that simply means the JMS API. This is also a statement that I can get on board with. In a majority of cases, for remote communication today on the web, REST is a very good choice. Probably 80% of applications should be using REST. Purists also take for granted some interesting concepts that are not so simple. So they say that if you are doing microservices, you better be very good at testing, you better be very good at DevOps, and you better be very good at things like continuous delivery and continuous integration. Honest question, how many of you can say that you have these concepts pat down and you have a complete control over these things and you are a master of these things? Testing, DevOps, continuous delivery, continuous integration. Okay, 1, 2, okay, some very brave or arrogant, maybe, people in the room. The reality is I wouldn't raise my hand with this either. These are complex concepts that we are still as an industry grappling with dealing with these concepts. So do I agree with this part of the purist definition of microservices? I absolutely do not. We will, as we explore deeper into this talk, what you will see is that there is a certain flavor of microservices for which these are essential tools. You absolutely need to do these things correctly: automated testing, continuous integration, and DevOps. If you do not do these things with that flavor of microservices, yes, you are guaranteed failure. But what I will also tell you is that a more pragmatic approach to microservices, the one that I believe is appropriate for a majority of applications, do not require these things to be true. Okay, you do not have to get these things exactly right. In fact, you may even get away with not doing these things at all, if you so wish, if you're using a certain more pragmatic view of microservices architecture. The purists, which brings us to our next and most important point. And if you don't get anything else from my sort of explanation of what I believe pragmatic microservices are, this is the one you really need to understand. Purists will tell you that microservices are all about fine-grained microservices. They're very focused on that. So you'll see some statements like, oh, if you have more than 200 lines of code, you don't have a microservice. Microservices are like building codes in Paris. It has to be a certain size, and if it's beyond that size, then you no longer can call it microservices. This, to me, is absolute 100% religion. All right. Microservices is not about the size of services. It's not about the size of your deployment unit. It is about architectural goals. If you've accomplished valid, legitimate architectural goals, what the size of your individual unit for a service is completely irrelevant. Okay. Moving forward. So now that we've talked about some of this, you may get the impression that, oh, I really don't believe in microservices at all. I think it's sort of a hogwash kind of thing. Well, part of that is true. Okay, I do think there's a bit of hogwash element to the microservices argument. But if it was complete nonsense, frankly, I wouldn't bother getting up on stage and talking about this. I would simply let it die its dignified death in its own time. I do believe there is a kernel of truth. There's an element of truth in all of this. And we would be foolish if we ignored it altogether and didn't try to understand what is truly valuable about this. So in order to understand this, let's first understand what are our problems in life. What are the problems that enterprises face on a day-to-day basis? Majority of enterprises. This is not going to be true of everyone, but a majority of enterprises. These problems are actually relatively well understood. If you look at most responsible IT analysts, they will tell you what these principal problems are. What are the defining problems of our time in enterprise IT? First and foremost, they are meeting the goals of the organization and demonstrating business value. Okay? Number two is operational stability. All right, having a stable, well-run organization that doesn't go through ups and downs and sudden surprises. The third one, and perhaps the most important one, is things related to maintenance. Okay, being able to maintain and sustain your application. Okay, other than the short burst of initially creating your application, this is probably the most important thing that you'll do. Software lives most of 80% of its life in maintenance mode, and maybe, to be very generous, about 20% in development time. So, does microservices help you accomplish any of these things? The bad news is it's strikeout for 2 out of 3. It won't really help you solve the basic problem of understanding your use case and delivering business value. It definitely will not help you. You'll see this in a moment with operational stability. In fact, it will probably make things worse in that regard. So the thing that microservices will help you with, the pragmatic value proposition for most of us, is that microservices will help with maintenance. Why is that? So, the reality of most software is that software is subject to entropy. All right? As time progresses, software systems get harder and harder to maintain. And the level of entropy increases more as the size of the system increases and the number of people working on a single code base increases. If you have 2 people working on a bit of software and it's relatively small, maintaining quality over the long run is easier. If you have 30 people working on a very large code base, For any development manager or any architect, maintaining quality and stopping entropy from taking over the system becomes harder and harder. So again, responsible analysts have an idea of what a sustainable bit of software looks like and how the team structure looks like. By and large, our industry consensus is around 10 to 12 developers. Okay, if you have 10 to 12 active engineers working on a bit of code, working on a code base, you will have a reasonably sustainable code base over the long run. So this, my friends, okay, is where the kernel of truth in microservices really are. You should be thinking about breaking down systems if you've crossed or you are very close to crossing the threshold of around 10 to 12 engineers. This is when you need to think about how do I start decomposing your system. Before then, you are violating the KISS principle because you are doing premature optimization. Okay? Anyone remember Daichkara's quote about premature optimization? What is it? Somebody? Premature, yes, premature optimization is the root of all evil. All right? So this is really the problem that microservices are designed to solve. Now, the good news is, when you need to do this, when you need to start thinking about decomposing your systems, oftentimes your business conditions and your system conditions will make this obvious for you. So for example, some obvious lines of demarcation of systems are departments. Okay, so if you have a single logical system, but your application really goes through several different distinct life cycles, and those life cycles are mirrored by the structure of your organization, well, that gives you a very logical place of how to segment the application, right? So each department should have its own subsystem, and the subsystems talk to each other over time. The other obvious boundary line is system requirements. Okay, so you may have certain technological requirements that make it obvious that this part of the system is different from the rest. A classical example is things like archiving and reporting. Okay, these are usually distinct concerns from your online transactional system, and hence a good subject of breaking down and decomposing into its own subsystem. Some of the other arguments made for microservices that I don't always agree with, but some of them I do, is that distributed systems can help you deal with modularity better. There is some truth to this. So, in reality, the real problem that we're trying to solve here is one of modularity. And you might make the legitimate argument that, okay, in order to make modularity, well, you don't really need to physically break down the system. You can simply use the modularity techniques that we already have. Java packaging, okay, package names, creation of jars. This is another way of achieving modularity. Well, the reality is that maintaining discipline in a locally maintained modular system is significantly harder than if your modules really are physically separate across a network. Okay, then you have no choice but to deal with decoupling. Okay, so if you have a locally produced system that uses nothing much more than local modules, you're much more likely to break the rules or bend the rules when things are inconvenient, which, let's face it, it does, right? When you're sitting there at 2 a.m. in the morning trying to solve this problem, you're not going to be thinking, oh, how do I make sure I don't break my modular boundaries? Your goal is going to be producing that bit of code. If that system is distributed and really there is a physical network boundary that you need to deal with, you are less likely to slip up. All right? Another argument made for microservices is that they are easier to scale. The simple theory here is that take a bit of code, an application, throw more hardware at it, it's going to perform better. Right? What's a natural way to do that? Well, let's break down the application into several parts, and then we can throw more hardware at it. Is there a legitimacy to this argument? Yes, there is. There is a degree of legitimacy. But the big problem is that you do not need to, it's sort of a circular argument. Because in reality, we know how to throw hardware at a bit of software already. Okay, it's simply horizontal scalability. Right? You simply make a copy of the entire cohesive monolithic application that you have and put that copy on another machine. That's it. Okay, and believe it or not, you will achieve a great degree of scalability just by doing that. In all reality, the applications that most of us work with are not dealing with millions, tens of millions of users. We can easily get away with simple horizontal scalability. There is a case where there is no other choice but to do truly distributed systems. Okay, in other words, decompose your system and then assign that subsystem to a horizontal cluster. But that will not you will not be approaching that problem until very, very late. Okay, so again, remember, premature optimization is the root of all evil. All right. Finally, some proponents of microservices will say, oh, microservices is great because it opens up the possibility of polyglot programming. You know, we have all these multiple modules. They all talk with REST to each other. REST is technology agnostic, and hence all of these different parts can be written in different programming languages. How many of you actually work in a polyglot environment? 3 people. Why is this? The reason for this is that organizations do not actually tend to be polyglot programming oriented. Why is this? Because it's a maintenance hazard, right? So if you have a team of 5 developers and they all are specialists in 5 different technologies, well, that's a problem for anybody, the architect or the manager maintaining this project, or the owner maintaining this project. What happens if this one individual leaves? Well, suddenly you not only have a problem of assigning a person that can maintain this code, you better find somebody that also knows the technology, right? So this is also an unlikely argument. The reason I have this box out there is to emphasize the fact that we really know how to do all this for a long time, and we've known about these pros and cons for a long time, because I'm a proponent of something called domain-driven design, and in domain-driven design for 10 years we've had a thing called a bounded context. And I won't go into the great details of it, but the reality is that we figured out how to do decomposition of larger systems. And the same thing that microservices is claiming is a new thing for the better part of 10 years. Okay, so you should look up the literature for bounded context. And it will tell you, it will tell you exactly the same things that I told you today, is how do you go about taking a larger system and breaking it down in a sane way. So finally, let's revisit from a technical standpoint what exactly the trade-offs are. What are the risks in distributed systems? We know the benefits, right? We just talked about what we're after. Let's now talk about what the hurdles are that we must cross in order to get there. First and foremost, we've known these things for a long time as well, and none of this has changed. Okay, no great fundamental technological breakthrough has occurred that make any of this false. All right. First and foremost is that distributed systems are operationally challenging. All right. It's going to be significantly harder to administer, deploy, and monitor a distributed system. Very simple, commonsensical thing, right? So what's easier to maintain? A single manage, monitor, and deploy a single application running on a single physical cluster, or 10 applications running on 10 logical machines, right? Very obvious. Also significantly, development and maintenance cycles are harder with distributed systems. Okay, doing testing is harder. Suddenly, if you have a bug, you have no idea whether that bug was introduced in your code, all right, or 3 layers down, okay, in your remote invocation chain. Debugging is harder for the same reason. Runtime diagnosis is harder for the same reason. In a local system, we'll set a breakpoint, okay, and trace through your breakpoint, and lo and behold, there's probably your bug. Over here, no such possibility. You'll have to set up remote debugging on code that you potentially do not own. There are similar challenges around reliability and consistency. I won't go into great details of this. I'll let you think about this. But these are all extra challenges that you need to deal with in distributed systems that do not occur in systems that are not distributed. Another big challenge with any kind of modularity effort, especially one that is remote, based on distributed systems, is code duplication. Okay, even in a very simple case, in a remote system, you will have DTOs, okay, that duplicate each other. That code, and in a worst case, if your functional boundaries are not properly decomposed, what you will happen is that you'll wind up creating local copies, local independently maintainable copies of things like your domain model and your business logic. Imagine that for a second. Okay? So will that increase your agility? No. Because now, when you have a system requirement change, not only will you need to make that change in one place, you better make sure that that particular change is propagated across every single local copy that you've made of it. All right? If that sounds buggy, it is. Finally, there's a whole bunch of other. Finally, all of this increases your skill and levels for development and operations. This goes to the fundamental other problem that we have in enterprise IT, namely resources. Okay, so if you're dealing with microservices, it's going to increase your level of resources that you will need, okay, to maintain the system. I won't go into the great details of it, but there's another element to all of this. And again, a very fundamentally important element that's been well understood for a long time. It's something called the fallacies of distributed computing. How many people have heard of that before? Not many. Okay, so you should know this. If you are an engineer, this is something you need to know. If you're an engineer dealing with distributed computing, you need to know what the fallacies of distributed computing are. This is something that came out of Sun Microsystems, okay? Think about that for a second. This is the company whose motto was, the network was the computer, all right? And then they came up with the idea of what the problems with distributed systems are. These are things like latency, okay? So whenever you have a network and serialization, deserialization, you will incur a performance penalty. You will incur potential security hazards. You will incur potential maintenance problems. You will incur potentials for failure, unexpected failure that you must handle. So what is the bottom line at the end of the day? We know what the benefits are. We know what the costs are. The benefits do not always outweigh the costs. In fact, in a majority of cases, they do not. Hopefully, it will be very obvious to you. The bottom line, then, therefore, is that you should make use of monoliths as long as you can. Okay, you apply the KISS principle because monoliths do not incur all of these penalties. Okay, so use it as far as you can, take it as far as you can. The second reality is that the majority of systems that do need microservices do not need these fine-grained microservices. You do not need hundreds of these. What you really, in most cases, will need is subsystems, rational, reasonable subsystems. And I believe most of you all may already have that. So these are cases where you have peers of systems. You have one larger logical system across your organization, and then that system is broken down into parts. Right? So you have perhaps departmental applications, and each of these are peers, relative peers of significant size. The other approach that I'll say is a next possible hybrid is that let's say you've for some reason you haven't done a very good job of modularizing your application by creating subsystems, and you do have a very large monolith. One way you can go about managing that situation is by creating a hub and spoke model. So you have your large monolith, and what you'll begin to do is identify pieces that you can easily break off. Okay, and you'll have one large system with a lot of smaller satellites. That's yet another common and likely model for microservices. Who needs microservices nirvana? In other words, a whole bunch of small services all over the place, all around 200 lines of code. There is a class of applications that actually do require this, but it's unlikely. It's a very rare case. For a majority of folks that are doing this, it's going to be relatively greenfield applications. They will not have much resource constraints. Their principal driving force is going to be time to market. Okay, that's what microservices in the end gives you. It gives you agility above all. All right. So if you don't care about any of the costs and all you care about agility, well, this is the right solution for you. Finally, if you're not convinced by the last 20 minutes of my talking, this is a network topology of the only known microservices system. One of the poster childs. Anyone can guess who that is? Anyone want to guess what this company is? Netflix. Yes, this is the only known diagram of Netflix's network deployment. Okay, this is one logical system. I'll let you look at this picture for a second. Okay, think about if you want this to be your reality. All right, the reality is that this is not for everyone. This is for a particular niche problem. Okay, it's a good, elegant solution for a particular niche problem. Probably not for the most of us. All right. So let's decide. Sorry, let me just get a drink of water. Okay, moving on. All right, so let's decide for a moment that, okay, we're convinced about all of this. We're going to create sane microservices that are coarse-grained, relatively similar to what we already have, and just a little bit more decomposed. What does Java EE has to offer? Well, the answer is it offers quite a bit. The reason for this is that Java EE from day one was designed for distributed systems in mind. Okay, so as a result, we have the right set of tools that you need for distributed systems. One of the most important bits being the things that will support remote protocols, and we support pretty much all of them in Java EE today. We have support for REST via JAX-RS. We have support for certainly SOAP. Okay, via JAX-WS. If you don't want that and you want to do messaging, well, we have an excellent messaging API called JMS. If you don't want to do any of that, there's another very nice protocol out there that just came out as part of HTML5. It's called WebSocket. Well, again, we have very good support for that as well. And we have support for other things like RMI, Corba, you name it. There's no known major protocol out there that isn't supported by the Java EE platform. What you also need is a way to translate. Okay, well, so when you're doing this network protocols, you need to serialize and deserialize the payload. Again, we have everything that you could possibly need. We have support for XML processing via an excellent API called JAX-B. We've added very good support for JSON. We'll continue to strengthen that. If you don't want to do any of that, well, we've had support for Java serialization and the like for ages. All right, and you have the rest of the backend APIs. Hopefully, I'll make it hopefully, I've made it obvious that you're not necessarily dealing with services here. These may simply be subsystems. Okay, in which case they're not just a headless facade. They may have their own UIs. Well, we have excellent tools in the UI framework space as well. Okay, the principal one being JSF. Highly popular, even in a very competitive web framework space, it's still the leading framework even today. And of course, we have all of the backend services that you do. We have JPA, we have EJB3, we have CDI, pretty much all of the basic tools that you would need to write good, sane applications, either a monolith or a sensible microservice. Beyond this, you have to remember that Java EE is not just a collection of APIs. Typically, Java EE runtimes will give you more than these things. They will give you things that are valuable operationally when you go to actually deploy a production system. And believe it or not, again, these services come in incredibly handy, and they become even more important in distributed systems. Again, not an accident. So things like administration and monitoring, hopefully I've made it obvious why this is important when you have a larger system. If not, okay, keep this in mind. High availability, okay, again, how do you manage a large-scale cluster? Well, we've had the answers for that in Java EE runtimes for ages. And we have good answers for how do you run these applications on a network in a secure fashion, and how do you manage resources, so connection pooling, thread pooling, and the like. All right, so with that, I'm going to jump into a quick demo. I won't spend too much time on the demo because I don't have that much time. All the demo code is available to you. It's on GitHub. It's actually another gentleman that I presented this very talk on, created and published the code base. His name is Steve Millage. He manages he founded an application server called Pyara. Some of you might have heard of that. Same gentleman there, so feel free to take a look at the code. I believe he's done a good job of having a set of startup instructions. So if you want, you can go onto that website and actually download this code yourself. All right, so let me show you our application. I have it up and running on NetBeans. There's two different aspects of this, two different modules of this application. One is called Cargo Tracker, and the other is called Pathfinder. I'll discuss that in a second. But let me first show you some of the runtime characteristics of this thing. So I'm going to take Pathfinder, which is a smaller application. I'll explain what this is about in a second. Let me do a clean and build. Notice the application time that it took to do that. 3 seconds, okay, almost about 4 seconds. Now let's go ahead and do a deploy and run of it. Okay, it's up and running. How long did it take? 1.2 seconds, less time than it takes to build the application. Let's now take Cargo Tracker. We'll do the same. Let's do clean and build. Time it took 6.5 seconds. Let's now actually deploy it. Okay, it's deployed. Let's take a look at the time, how much time it took to deploy that. 3 seconds. Let me tell you, this is a 20,000 line application. Okay, there's about 150 Java classes that were just deployed. How is this possible? It's because you're dealing with Java EE. Right? I'll let you take a look at this. Take a look at the code for this yourself. Okay. In the end, what we deploy, I'll show you, I guess, really quick. It won't take long. Let's take a look at the Cargo Tracker WAR file. Okay. This WAR file, remember, 20,000 lines of code, winds up being 893 kilobyte deployment. Pathfinder is 298 kilobytes of deployment. All right? So this is important. These are important things to understand. This is one of the things that Java EE is giving you in a microservices environment. It's extremely lightweight, and its runtime mechanism is that simple, all right, to do. So let's take a look at the application. This is basically, I'll let you take a look at the application on your own later. This is named Cargo Tracker. As you can imagine, what this does is that it tracks cargo going across the world. Okay, so there's various interfaces to doing this. One is a tracking interface, similar to what you may see for USPS, for example. Let's say I have a bit of a cargo that I want to track. I'll go ahead and enter my tracking ID. Okay, it'll give you some information about what the tracking status of this cargo is. I can go into the landing page of the administrator. Okay, this is all of the cargo that I have registered. I can do things like book new cargo and the like. Okay, so create a new data point here. There's also a mobile interface. Okay, this is intended to be a mobile web interface, and this is people in the ports entering cargo information. So without going into great details of it, non-trivial bits of functionality. Again, about a relatively large application. This is one monolith. Okay, it's one application. And I would venture to say this is very easily maintainable, okay, by a team of maybe 2 or 3 folks. All right, very, very easy to do. If I actually tried to break this down any further, what would happen? All of these parts of the application that you saw uses a single a domain model and a single set of business logic. Okay, if I tried to break this, I'd have to create local copies of each of these. So it doesn't make any sense, and I'll let you verify that yourself when you take a look at the application. Is there a microservice possibility here? The answer is yes, there is. Okay, and let's take a look at that next, which is what the Pathfinder application comes in, where the Pathfinder application comes in. So I'll go into the landing page. You'll notice that there is I have DF789. That's a bit of cargo that has been registered but not yet routed. Okay, so let's take a look at that. Okay, as you can see, it's going from Hong Kong to Melbourne. What I can now do is I can route this cargo. All right, so if I route this cargo, this will essentially go through a traveling salesman problem. Okay, so I have a source and destination. I have a set of ships that I know the schedule of. Okay, they go across the world. So now it's a matter of matching this with that. All right, it's a traveling salesman algorithm. I have two possibilities, much like in an airline reservation system, let's say. And I'll just pick number 2. All right. So what is happening here? The thing that actually does the mapping, all right, actually figures out, given a source, destination, and deadline, what are the routing possibilities. That is actually its own separate service, and that's what's in the Pathfinder module. Why did I break this out into a separate module? By and large, when you take a look at the code, what you will find out is that this part of the system is very different from the rest. Okay, the rest of the application is very much crowd-oriented. It's just looking up data through a domain model and displaying data from a domain model from the database. That is it. There's not much more to this. The most algorithmically complex part of this system is actually in Pathfinder. Okay, it's significantly different. It's apples and oranges. Simple CRUD stuff, a lot of algorithmic stuff going on. And likely, in a realistic system, I will need 2 sets of developers that think in very different ways in managing these systems. Okay, the CRUD part of CRUD part of the application versus the more algorithmically complex part of figuring out the path from A to B. And it's also likely that these things change in different velocities and have very different system requirements. Okay, the path tracking, the Pathfinder application likely is much more agile and changes much more frequently than the CRUD part of the application that is dealing with more or less static business rules. All right, so this is a good application of where I could apply a microservice. All right, so this makes sense to break this out into its own component and give it to its own team that can deploy this service in whenever they want. And these 2 services, I won't go through the code, but they are communicating via REST, okay, using JAX-RS. It's a JAX-RS endpoint. Pathfinder is a JAX-RS endpoint. Cargo Tracker accesses Pathfinder through the JAX-RS client API, using nothing much more than a DNS name. All right, so DNS name is your routing mechanism here. They are talking with each other using JSON, but the same endpoint will also support XML. So the endpoint actually talks both XML and JSON, but we happen to be talking JSON in this case. Okay, it doesn't get any more simpler than this. This is it. This is really, in the end, all that you really need to create a pragmatic microservice. All right, and and as you can see, it's very agile. Okay, it's very agile to do so in Java EE because of the way that our architecture works. Very, very small WAR files that deploy very, very quickly. All right, moving along. I don't have much time. All right, so I'm going to skip over this part. The goal of this particular slide is to sort of completeness. Remember, I was talking to you about commercial interests, okay, sort of polluting the basic idea of why microservices are valuable. These are some examples of that. In each of these cases, the proponents of these things will tell you, you absolutely really need this, right? If you don't use this, you're not doing microservices. Sounds to me a lot like a snake oil pitch, all right? You need this. No, you don't, right? The reality is that for most pragmatic microservices, you actually don't need these things. These things are helpful. They become more and more helpful when you are dealing with very, very fine-grained microservices, the kind of thing that we saw in Netflix. Netflix needs these things. You probably don't. Okay, so you should very carefully judge and use the case principles and figure out when do you need these things. But if you need them, they are there for you. And by the way, all of these are in the Java EE ecosystem. These top guys, Wildfly Swarm, Pyra Micro, Cumuluzi, Tommy E embedded, well, these are nothing much more than Java EE APIs, the very same ones that are available in something like Glassfish, okay, delivered in a slightly different way. All right. Moving forward, let's do the conclusion. I will just overextend my welcome by a little bit and talk to you a bit about the resources. So what is in summary? The summary is simply that microservices are a pretty old idea. We actually know a lot more about microservices than we realize. The reason it's so, we are confused, a lot of us are confused, is because we're using new terminology for very old ideas. Because these ideas have survived for so long, there is something valuable in them. But they are not always necessary, okay? And when they are necessary, you don't have to jump into it whole hog. You can take an incremental approach to utilizing these concepts, okay, as you see value. And hopefully I've also shown you that Java-E is a capable platform to do that, okay? Unless you're really talking about very, very fine-grained microservices all the time, okay, Java-E as it is today will help you quite a bit to get there. And the parts that is not solvable yet by the Java-E ecosystem, well, guess what? There are things in the ecosystem that are going towards solving those problems, namely, the things that we talked about on this slide. All right. I will give you the exact location of this slide so you can take a look at it later. But I do want to share some resources with you before I sign off. The first resource that I will share with you is from Martin Fowler. I have to say I'm disappointed with Martin Fowler. The reason I've been disappointed with Martin Fowler for a few months. I'm less disappointed with him now. The reason I'm disappointed with Martin Fowler is that he started writing this set of articles sort of promoting microservices, and the tone of those articles are hopelessly optimistic, okay, hopelessly hype-oriented. But what I have seen from Martin Fowler is that of late he's changing his tone. All right, his tone is becoming much like sort of the overall tone of this talk, if you will. And a good example of this is the latest article from him. It's called Monolith First. So if you want to learn more about sort of the theory of microservices, a lot of what I just told you in this talk is actually, to my surprise, in Martin Fowler's material as well. But your best approach, if you want to match the tone of my talk, is start here. Don't start with the very first article that Martin Fowler ever wrote about microservices. Start with this one. The second one is where I still am disappointed in Martin Fowler, because he still continues to deny the fact that microservices and SOA have much more in common than we realize. And this is actually another article written by another very good gentleman who essentially has the same viewpoint as I do and is a critique of why we really should be more careful about this and why we need to set the proper historical context and perhaps acknowledge that a lot of what we are talking about in microservices have already been talked about in SOA. The rest of these are Java-E resources. If you want to learn more about Java-E, I won't belabor these too much. I think that's it. I have just about a minute left. With that minute, I will take some Q&A, and then I will also tell you how you can get to the slide deck. So it is on SlideShare. And it is a second talk. This is one of the very recent talks. As you can see, this talk is only 4 months old. Okay? So there you go. It's fairly simple. It's slideshare.net, Reza Rahman, my name, / Java-E-microservices. Okay, that's the URL for this slide deck. It is available in PowerPoint. If you want to download it and tweak it and make your own version of it, please feel free to do so. And it does have the GitHub URL for Steve's demo embedded in there as well. Okay, very good. Thank you very much. I appreciate 45 minutes of your time. Hopefully I will see you soon. And I will take any questions until we're kicked out of this room, which is probably very soon. Yes? Okay. We are finished. Thank you very much. So catch me later and we'll have a chat.